Okay, good afternoon, everyone. Welcome to the International Perspective Webinar Series. So today we will be discussing, our speaker will present about high voltage insulation materials. Our speaker coming from University Technology Brunei, Brunei Darussalam. So I believe today everyone will learn so many insights from her. But before we start our session today, I would like to remind all participants to open their camera and use the virtual background provided by my college in the chat box. So our session today could be more lively. Okay, first let me introduce our project. So the International Perspectives webinar series is a series of international online knowledge lectures jointly led by the CMU, China ASEAN Technical Education Cooperation, or CATECP, and co-hosted by International Youth Culture and Education, okay, AMG, and also Go Study. The program is expected to invite 1 until 2 school faculty members to give webinars each month, aiming to enhance and enrich the growth of knowledge and broaden the horizons of learners in the Southeast Asian region by inviting experts from different countries and fields to provide high quality and universalizable online lectures that will help the learners to acquire specialized knowledge through knowledge sharing and cross-cultural understanding. So for our speaker today has joined us, Dr. Nur Asia binti Muhammad. Dr. Nur, can you hear my voice?
Yes, I can.
Okay. So Dr. Nur is Deputy Director for Trisat University Technology Brunei since July 2025. And then she also the Deputy Director, Center for Research on Agri-Food Science and Technology, or CRAFT, at University of Technology Brunei. But she just finished this position since 2022 to 2024, and she also senior assistant professor at Faculty of Engineering, University of Technology Brunei since 2021 until now, and she's a retired associate professor at University Science Malaysia. While her professional field are high voltage engineering, electrical insulation, condition monitoring, dielectric materials, renewable energy, and smart grid systems. Dr. Noor, I would like Dr. Noor to present her her materials or topics today. So you can slash screen share now, Dr. Noor.
Okay.
Okay, and the time and screen is yours.
Okay, thank you. So let me share my slide. Okay. So can you see my slide?
Yes, I can see it.
Okay. Okay. Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to all. Let me begin our today lecture. I'm Dr. Noasia Muhammad. I'm from UTB, University of Technology Brunei, which is one of the 3 universities in Brunei. So I'm joined UT as introduced by the chair. I'm joined UTB since 2021. Previously, I'm working with USN, University of Science Malaysia, for 6 years, and before that, I'm with Institute of High Voltage and High Current, University Technology Malaysia for 16 years. So for today, I would like to talk about introduction, beginning to the high voltage into insulation materials. So for today's content or today's lecture, firstly we go for the definition and classification of high voltage. Then we will see each main component in high voltage and what are their insulation media. Then after that, we go for application of each insulation material. And lastly, we will see how high voltage system reliability and economically are being assessed. So before we go further, so let us know what is the high voltage, what we can consider what is high voltage. So for electrical, we are born with the standard. So all our works or our testing are based on the standard. There are a few standards around the world. So the most they use for Asian is IEC standard or American standard. So if like Malaysia, we have a Malaysian standard. Like Brunei, they adopt IEC standard. So for IEC standard, they define high voltage is the voltage larger or greater than 1 kilovolt for AC, while for DC is 1.5 kilovolt and above are defined as a high voltage network lah. So for US standard, which is American National Standard Institute, ANSI. So the definition is a bit different. ANSI C841 .1-2020 define the high voltage is a voltage that above 115 kilowatt to 230 kilowatt. Then they give actually in IEC we also have extra high voltage, which is then we have extra high voltage which is above 345 kilowatt, and for ultra high voltage is which is 1.1 1100 kilowatt. So not too many country have ultra high voltage. In China, in Asian region, like Malaysia, Brunei, we don't have that one, but like China, Australia, they have ultra high voltage network in their system. So British standard, BS standard, mostly following the IEC, but sometimes they have their own definition as well. But for high voltage, British standard define high voltage as a voltage higher than 1 kilovolt AC and 1.5 kilowatt DC. And they have additional, which is the voltage difference between the conductor and earth, which is phase in power electrical, we call it as a phase voltage that greater than 600 volt or 900 volt DC voltage. So this is the classification for high voltage. So after that, then we can how we can generate. Let us know how can we generate high voltage. So high voltage actually first was discovered from a natural form, which is from the lightning discharge. So the lightning discharge have more than 1,000 kilovolt. So then the high voltage also can come from the man-made, or we can call it a synthetic high voltage, which is from the high voltage generation or from the high voltage transmission or distribution or in the laboratory generation. So application of high voltage, actually we live within it, only we don't know because you use electrical 24 hours, 24/7 in your life. So the application mostly, the application of high voltage is in the electrical power, because from the generation to the customer side, if the generation is far, so we need to have high voltage network in order for us to deliver the current or deliver the electrical to the customer. So then in the industry, heavy industry, we have heavy machine. Heavy machine require high voltage and high current. Some machine require high current. So in the oil and gas industry, also in agriculture, where now we have a lot of smart devices or motor devices in the industry, also in the agriculture. So high voltage also have a lot of application in medical. So if you have experience using MRI, CT scan, so most of the machine are operate in high voltage. And also for laboratory, last time I'm working with Institute of High Voltage. So there is a research laboratory and also the testing and calibration laboratory. So most of the electrical equipment or equipment that work in the industry that connected to high voltage must be testing and calibrate before it can be used. So in laboratory, we also generate high voltage for research and testing. So nowadays, there are a lot of electrical transport. So like high-speed train, electrical train. So this transportation, electrical transportation is using high voltage in their operation. So the other application are in the utilities. You go to shopping mall, you go to the hotel. Most of these utilities, airport, they have high voltage. They have high voltage equipment transformer at least for them to supply to the building, to move the lift, to move the escalator, to power up the aircon. Then the high voltage application are also being applied in this kind of buildings. So let us see what is high voltage in our power system. So in power system network, we have 3 parts, which is, okay, we have the generation part. It can be categorized into 3, which is generation. Then we have the transmission, and then we have the distribution. Before distribution are connected to the load, which is as the user, the consumer. So in generation, most of the generation are in the medium voltage, which is around 11 kV. Then we have the transformer, we call it as the equipment that step up the voltage to feed into the transmission line. So this transmission line, normally the length of the transmission line will give how high is the voltage. So the longer the transmission line to the customer, which means the long distance between the generation to the customer, the more high voltage we require. This is because we need to transmit the same power with minimum loss of current. So if we put high voltage, the current will be lesser. Then they can reduce the loss in the transmission line. So then we have the substation, where we in the substation we step down the voltage and to the customer rated value. So to your house, which is around 120 volt, 140 volt, depend on where is your country, rated power frequency, and also power voltage. Then we have the industry, second stage of customer, which is small industry, around 11 kV to 33 kV. Then we have higher, more customer, which is heavy industry. So this is where all the high voltage being used, all the equipment being placed. So then we go to the, then we go next to the, what we call it, what is the important factor in high voltage. So in high voltage apparatus, there are a lot of equipment, diverse condition, diverse stress level, but the main factor that this equipment need to be considered is what is the conductor selection. Conductor is the equipment that carrying the current from the generation to the customer. So insulation design, because it's a carrying current, high current, or that produce high voltage. So the important is the insulation design, because to carry the current, we need only solid material. But to make the operation safe, we must design the good insulation system. So in high voltage, actually the most important is the insulation design and electrostatic profile design. I believe everybody have experience in electrostatic, which is from the normal voltage equipment. But in high voltage, the electrostatic is much higher and is much dangerous, which is if you experience high voltage electrostatic, you will only experience it once, and we will not. After that you will be not here anymore. So that's why electrostatic profiling design is very important also in high voltage system. So, but the main focus today, we are not looking on the conductor insulation and also electrostatic profiling design. The one that we are looking is the insulation system. So, in high voltage insulation media, actually there are 5 major category, which is a solid insulator. We will go one by one. Then after that, we have a liquid insulator. Then we have gas insulator. We also have vacuum insulator, and we also have combined. So the figure here, example of vacuum insulator. This one is the, we can get gas insulator. Then we have, here is the liquid insulator. Then this one is atmosphere, which is, we can call it also as a gas insulator. So what is the purpose of the insulator? Is to insulate voltage carrying conductor against other as well as against earth. So the live wire, which is the conductor, they cannot touch each other. It will become short circuit, or if they also cannot touch to the ground. So they can it's become fault to ground. So they must be alert in their journey. So now we go for solid insulating material. So there are a lot of equipment. So there are a lot of type of insulation material, solid insulating material. But today I present the basics, which is the major solid insulating material used in high voltage equipment. So there are rubber or synthetic rubber. So this is an example of rubber in cable. So this is one cable lay. There are rubber here. So there are also a polymer. So here I don't have polymer. So we have glass, also insulation. We have clay. This one is made from clay. This is glass, the white one. This one is a glass insulator. This one is the clay insulator. This is a conducting wire. So it's insulated from the live wire to the tower. So here is the transformer. So we have a canaf. So here is the canaf paper. So it's insulated between the winding in the transformer. And we also have wood and craft paper. So we also have craft paper here and also wood at the equipment. So the other thing, the second insulating material type is the liquid. So nowadays we have 3 major type of the liquid insulation base, which is mineral oil base. This is we have also synthetic oil base. So then we also have a vegetable or plant base. So this is the mineral base. This is the vegetable base. Then synthetic, the color mostly is white color, clear color. So this is the equipment. This is a transformer. Inside we have an oil to insulate the equipment. So we also have gas. The third insulating material, major insulating material, is the gas insulation. So this is FS6 switchgear. So inside this pipe there are gas, where every time they are disconnected, this gas is used to insulate the connecting. So we have 3 major types, which is nitrogen, FS6, and air. So air also considered as a gas. Okay, so now there is a 3 basics. Now we will go detail on each application of the major high voltage equipment and their insulation material. So we have 6 major equipment in high voltage, which is power transformer, the one that step up and step down of the voltage in the high voltage power system network. So this is like a heart of our power system. Then we have a rotating machines in the generation, in the user side. We also have a circuit breaker. Circuit breaker is the protection system. So disconnecting and connecting the line. So we also have cable who carrying the current. from one point to other point. We have the capacitor bank. The capacitor bank is normally to maintain the power factor of the system. Then we have a bushing. Bushing is between the cable to the equipment. We connected through the bushing. So we will look one by one. So here is the insulating material. So why we need insulating material? So every piece of electrical equipment depend on electrical insulation material performance. So if the design is failed, so the equipment will fail faster. So the main major contribution to the electrical equipment design is that it's insulated, not its conductor, but it's insulated. So because it stops current to flow between the two coil or two conductor to be shorted or to the ground. So we want to channel our current to flow to the right way. So the main flow of electric current is in the desired part of the circuit. So we also use insulator to avoid current deviation, because current is like a car in the jam road. So they will find the shortest way to escape. So then the one that put the car in the channel is the insulator, or the current to flow in the channel is the insulator. So we want to avoid the short circuits or leakage current that will cause the potential drop. So there are four principles of insulation material application. First, we will insulate between the coil and the earth. So in insulation, in high voltage or electrical, there are conductors. It will be in form of coil or in form of straight wire. So we want to isolate between the coil and the earth. So we call it face to earth. Then between the coil with the coil, which is we have face A with face red with the face yellow. So there are in power system we have single phase system or three phase system. So that run together. So we don't want each phase to be shorted. So it must be insulated. So between turn in machine there are in one phases there are a lot of turns. So we also don't want to have a short circuit between turn to turn. Then we need to insulate the turn. So and also coil from the same phase to be shorted between them. So then we look the major equipment, power transformer. This is a power transformer. I believe actually you see this equipment because if you because most of the country there are transmission line and there are open substation. So this equipment normally placed in the substation outdoor. So you can see this one. This is the oil field transformer. So inside the equipment there are winding that carrying current, and this winding insulated by a few insulating material and submerged into the oil. So this is oil field transformer, the power transformer. Then this is dry type transformer. So this is three phase. This one is single phase. Single phase power transformer. So there are two types of insulator. Two types, which is oil or gas immersed transformer, and also dry type. So this is oil type. There are also gas immersed power transformer. Then this is dry type. So first to encounter lightning and such. So we know that in Asian region, especially in Indonesia, in Malaysia, in Borneo, we have a lot of lightning event. So because of our environment, humidity and density, so we have high lightning and event, and this lightning carry very huge current surge. So we need to protect the equipment. So this equipment can operate even though there are lightning strike in our system. So what that make this equipment operate properly is the withstand of the insulation system. So Then we have to look on detail of the insulation system. This is the construction of the power transformer. So there are three. This is three phase. So there are three phase winding here. There are high voltage winding and low voltage winding. Each of these winding have a insulation material. So this is power transformer. The power transformer will there are component of the component. The top is the bushing connector. This is where from the transmission line, from the line is connected into the transformer. So transformer function is to step up or step down. So when it enter from the higher bushing, so means it, and going up from the lower bushing, so means it's a step down transformer. So there are for this one is this is high voltage bushing, this is low voltage bushing. So because transformer is there are new transformer, most of the transformer there are auto gear to adjust for the load. So there are step changer. So there are motor here, motorized step changer. So and also we have a lower inside this is the core, magnet core. So the transformer work based on the electromagnetic principle. So then we have the we have the core here. Then we have the winding. So the low voltage winding is at the inside and the high voltage winding at the outside. So then we have motor drive here, control fan. Then we have the ladder. We have the conservator tank. So this is the temperature indicator. We have the radiator. So the oil inside the transformer have a function as an insulator and also as a cooling medium for the this equipment, because this equipment operate in a high current and high voltage. So then there are heat dissipation inside the operation. Then we use this radiator, same as what a radiator in car function, which is the heat. When there are high temperature, so the high temperature oil will be at above and going down and circulate. During the circulation, the heat is released. So some of the transformer we add fan, so to make it cooler faster. So it depends on what size of the transformer. So now we look on the detail of the transformer insulation. So we have conductor or turn-to-turn insulator. So here we have turn-to-turn insulator. Here most of it from the enamel for organic enamel for smaller rating transformer. We also have glass tape or paper wrap in rectangular here, which is for the large rating transformer. Then we have coil-to-coil insulator. We have the craft paper, then for small rating, and we have press board for the more higher rating, or porcelain for higher rating. Then we have the between low voltage and high voltage. In here we have the insulator as well. So we have a solid tube, we have liquid here. Oil will be submerged. This winding will be submerged in the oil. There will be oil here. So or gas, if gas will be gas. So this one to remove heat, because there are flux induced here. Then there are heat here. So from the core and coil structure. So then to improve the strength, we have high voltage coil to ground. So this one we have high voltage coil to ground at the bottom, because the tank, most of the tank of the insulator is grounded. So here is the insulating between the active component, which is the winding, with the tank. So to prevent short to ground. So maybe here we can look it closely. So we have turn-to-turn, face-to-face, so conductor or turn-to-turn insulator. Then we have low voltage coil to ground. Here we have high voltage to low voltage, like this is low voltage, this is high voltage. So we have the insulating material here and also oil inside here. We have coil to coil, then we have the high voltage to ground. So the major insulating material or insulating system. So then this is all the solid insulator inside the transformer. So these all, if they're all immersed transformer, we will use transformer oil to put inside the tank to become another level of insulation material, and also to as a heat dissipation material. So transformer will provide dielectric strength, insulation, and cool the transformer by circulating itself through the core and coil structure. So there are mineral base, like I said, there are mineral base, ester base, synthetic oil base. So last 20 or for I think in last 20 years, most of the equipment is the mineral oil. But since 2000 something, 2000 or late 1990s, there are new ester base. Actually, ester base is not new. They've been there before the mineral, but been stopped. Then after late 30 years back, they're coming back to ester base. And also there are synthetic base oil that cover the disadvantage of ester and mineral oil, but the price is different. So oil must be fulfilled the standard. So before this oil can be put into the transformer, so it must fulfill the, if I follow the IEC standard, it must fulfill the standard. They say it's a new oil, unused, so it must fulfill this IEC standard 60269. There are listed of testing and requirement that this oil must go through. So if you have new oil, you have vegetable oil, soya oil, or cooking oil, you want to make it as a transformer oil, you need to test it using the standard first and find what is the properties. Then you can do modification to improve if there are some properties is not good. So then there are different standard for different base material. So if this is 60296 is for mineral oil. So 770 is ester oil, which new oil. There are also standard for used oil, where the oil been used and you reclaim, or you reclaim back and want to use, then it's a different standard to use. So this is example, the properties of the transformer oil. So what we look on the transformer oil is the viscosity. The viscosity is a main important things, because this oil need to be act also a cooling medium, so it cannot be too viscous. So then the water content, breakdown voltage, this is a major one, which is the breakdown voltage. There are specific requirement limit. So water content, because water inside the electrical equipment at certain point is very dangerous. It can be a conductor. So then there are limits for water content. So then we look on the acidity, appearance, and other requirements. So oxidation level of the material. So then in certain area, the standard for low cold start energized temperature also important factor. If the transformer are being used at the cool or at the where we can find like extreme cool weather. So this LCSET is very important factor. So then we look closely inside the transformer winding. So there are craft paper or press board. So you can see the one is the example of press paper. Okay, this one is example a company. This is a press paper with partial epoxy rising coating. Then we have the two, which is the cylindrical cooling chain. Then we have the outer layer here. What you see is here, but inside there are a lot of other layering of the insulating material. So there are enforced pad, non-woven, epoxy resin implementation. So then we have for the crepe paper tube that wrap the winding. So this craft paper for electrical insulation are made from the craft cotton or craft and cotton pulp. This board is intended for dielectric and structural purpose. So beside the dielectric, it also structure purpose to make the winding at its place, because the shift of the winding will give different electrical strength. So it will produce high spot of electrical field. So to maintain it, the winding in the proper structure, so we need a good solid insulating material. So there are a few standards that we can refer, which is ASTM and also ASTM D4063 and also IEC 60415 F1 for the pressboard selection and also pressboard requirement. So this is example. If you buy the material, they will give you the pressboard application required according to IEC. So the thickness tolerance, the density, the weight. For us, the important is the dielectric strength in air, dielectric strength in water, in the oil, and oil absorbent. We don't want the press paper are very cannot absorb oil. So there are standard listed for the craft paper to choose for the equipment. Okay, so we also have gas insulated transformer. If oil, we call it SOIT. We also have gas insulated. So the purpose is same as a cooling medium and also as a insulated material. The difference we are using the oil and the gas. So transformer for oil can be categorized into four. It depends on what are the support to make the oil cool. So if the self-cooling means oil natural, air natural, which is the transformer without any fan, only have fins or tube. So it will be naturally cool. So then we have the forced air cool which is oil natural air force on earth, where we have oil circulated as naturally. The higher temperature oil is at the above. Then if we go to the fin, and we have force, we have fan at the fin to make it faster cooler. So we also have on-off, which is air force, all natural air force, all force, air force or transformer, where we have at the bottom of the transformer, we have pump that pump the oil to be circulated in the transformer, and also the fan that blowing into the fin. So we also have water cool transformer, oil force, water force transformer. This one where we add oil, water as a chiller to the transformer to make it more faster to cool. So this is the connection. So this is the oil natural or gas natural, air natural. This is the gas air force. So we have the fan, and also we have the water exchanger. Okay, so we go to the next type of the power transformer, which is a dry type. So the construction of the transformer is for the basic is the same. We have the core, we have the winding, high voltage winding, high voltage winding, low voltage winding. But instead of immersed in the oil or in the gas, this transformer are being been covered by the solid material, which is most of it is the epoxy. Epoxy resin. So there are no oil or gas. So the cooling will be natural air. Okay, then we go for rotating machine. So we have rotating machine where the application of rotating machine mostly at the generation side, where we have, if the hydro generation, we have the hydro turbine. If the gas generation plant, we have gas turbine. There are coal turbine also, and there are depend on what is the generation side uh, are made for. So these machine are categorized into three, which is small machine, medium machine, and large machine. So the large machine are very difficult to design, to be protected, or to design the insulation system. That is why most of the generation they go up to the medium level, which is up to 11 kV. Because this large machine, the insulation become more bigger than the machine because of the very high current in the system. So it will be more costly. That's why that the generation that more than 20 kV is difficult to be insulated. So the rotating machine, we have two parts, which is the machine have a stationary part and the rotating part. So then this machine, the insulation material are classified into 1, 2, 3, 4, 5, 6, 7 class. The classes are depend on the temperature. So the temperature, operating temperature that they can withstand. So there are paper insulating, which is class as Y. There are class which is Y A, which is the paper also, but implemented plus with there are nylon implemented with oil or other. So then we have class E, which is 120 degrees. We use polymer, which is polyethylene. We have cellulose. Then we have class B that can operate up to 130 degrees. We have mica, fiberglass, so asbestos. Then we also, I have a polyester enamel. We have class F that can operate up to 155 degrees C, which is as class B, but with the match with the other materials like epoxy resin. Then we have class H, which is up to 180 degrees, which is class B also, that work with the silicone resin binder, silicone rubber, aromatic polyamide, which is been mixed with the other materials. Then we have class C, which is operate above 180 degrees, which is also class B that that suitable for non-organic binder like a Teflon. So this is the picture of the insulating material. So in rotating machine, this is the rotating part, which is the rotor. This is the static part, which is the stator. So then we cannot use oil because it's a rotating machine. So we use solid material. So, but if the solid material, one is damaged, we need to replace. So the progression of the solid material have been studied quite a long time ago. We have class B and class E in 20 years ago. I think most of now going to 30 years ago. So then they are introducing of class F for high voltage application. Then they introduce class H for to reduce size of the machine, because if the insulator is big, so then the machine is heavy, so then it will be costly. So and it's not that efficient. So then now we are currently mixed at once. We have it's not now we have nano, we have micro material, or the combination compound of the material, insulation material. So, like I say, in the rotating machine, we have two parts, which is the stator part, the one who are static, not move. Then we have a rotor part, the one that turning in the system. Where then these two have a different solid insulation material type. So for stator, most of them is from mica base, nano polyester used for bicycle discharge protection. They also a fiber, glass fiber reinforced epoxy edge. Then in the rotor, most of them is the single layer glass or hard fabric. So or is a Nomex. So maybe some of you are very familiar with the Nomex. Now it's become famous. Yes. So then these insulating material are being selected based on what is the power rating of the machine and the operating condition. Now, like I said, we have hydro, we have gas, we have a few type of the generation type and operation condition. Then the motor and stator reliability. So now we go for the third major equipment in high voltage, which is circuit breaker. So circuit breaker is like a switch. So it's connect and disconnect the line. So device are enable to interrupt the operation. So at high load current and but also at very high large fault current. So it's divided into two, which is low voltage circuit breaker and also high voltage circuit breaker type. So circuit breaker once is on or off, we are so if fuse is burned, you need to replace it. But in high voltage application, the circuit breaker one is being interrupted, you can re-energize that. So this is a picture of vacuum circuit breaker. So inside this is the two conductor, separated conductor, two terminal, electrode, positive and negative. When there are fault, the terminal will be separated. The circuit will be disconnected. Where we put it here. So this is the main, then we lock it into here. So this is the main connecting to the load, to the system. So circuit breaker function should be able to close or interrupt the circuit within the effect of the ice type. So here where the circuit breaker should not operate if the machine is typing, because machine when it start they have a current, so the circuit breaker should not operate at this condition. So it should can define this is a starting current or this is a fault current. So then we have a circuit breaker must open automatically. So it must automatically disconnected. So but to reclose it can be automatic or it can be manually. So the gap because it's disconnected, so there are two terminals need to be separated. And when it's full open, the circuit should be disconnected fully. So must be capable to interrupt heavy current because it's under operation, there are high current. So when it's interruption, the force must be capable to interrupt the short circuit current. They must be capable to close back when or reopen back when there are faults. So and also must capable to carry short circuit current for short duration during the faults. So here, this is outdoor switching. So when we open the circuit, there are arcing. So in circuit breaker, the insulation material function or main major use is to quench this arc, this wire. So if you are in home, maybe you have experience when you open the switch or open there are sparking. That also we consider as arc, but there is a small arc. This is in the high voltage operation. So the in circuit breaker, the insulating material need must able to stop this arcing. So during operation, they can contact circuit breaker medium opening So the ionization that produce arcing. Then the circuit breaker material, insulation material need to stop this arcing as soon as possible. So for circuit breaker, there are a few type of circuit breaker, which is the miniature circuit breaker. So what we call it MCCB. So the arc quenching medium is the air at atmospheric pressure. So the operating range, voltage and capacity is between 400 and 600 volt for small rating current up to 5 megavolt. So we also have an MCCB at your home, but that one not category as a high voltage because it's at a low voltage level. So, but it's the same as here, miniature. The operating is same. So we have air circuit breaker, where air circuit breaker, the arc quenching medium is the air at the atmospheric pressure. So the operation is the suitable use at the 0.4 kilovolt to 11 kilovolt. So this one, this air circuit breaker. What you see here is the air circuit breaker. So the capacity of the system is 5 to 750 MVA. So we have bulk oil. The arc quenching medium is the transformer oil. We have minimum oil circuit breaker, also transformer oil. Then we have vacuum circuit breaker, where the arc quenching is the vacuum. We have FS6, then FS6 at certain pressure. Because for gas, pressure are very important. Gas or air, the pressure is important because FS6 property will not at the same when the pressure is not at that level, at the specific required level. So then we have the fourth equipment is the cable. So cable are the one of the main or the largest equipment in the power high voltage system because from the generation to the customer, the connection are through the cable, whether it's a bare cable or it's an insulated cable. So in here, in this lecture, we will focus on the insulated cable. For the transmission line, normally the cable are uninsulated cable. It's a bare conductor without an insulator. So because it's for the heat dissipation, because it's a high voltage cable, but for the insulated cable, mostly used at the medium voltage and at the distribution level, or under we call it as a ground or underground cable or submarine cable. So there are 4 types of cable in high voltage within power as a power cable. So it was categorized based on its insulation system. So first, there are polymeric cable. We have low density polyethylene, LDPE. We have high density polyethylene, HDPE. We have cross-link polyethylene, which is SLPE. We have ethylene propylene rubber, EPR. So they have a second type, which is self-contained filled cable. So paper or propylene laminated, insulated with individual metal shields and impregnated with the low pressure oil. Then we have the third type, which is mesh impregnated non-draining cable, which is the paper insulated with the individual metal shield and impregnated with the low viscosity polybutane compound. It's usually used in the medium voltage and also submarine DC installation. Then we have the last type, which is high pressure filled cable, HPFF cable, or we call it as pipe type cable. So cable that are put in the pipe. So paper insulated and installed in the trefoil in the steel pressure pipe, implemented with the high pressure non-degradable fluid. Then the fluid is usually composed of gas, FS6 or nitrogen at the specific pressure, normally at the 15 bar. So this is the construction of the polymer cable. So this is the conductor. It's very If you can see, the conductor is a small part, small area. The highest area is the insulating system. So we have the conductor to carry the current. We have the inner semiconductor layer. So we have the insulation layer. This is the SLPE, LIDPE, or other type of polymer. So then we have the outer semiconductor. Then we have the shielding. So this is for electric field distribution control. Then we have the armor, and also the outside is the jacket, outer jacket, mostly from the rubber. So SLPE was the first plastic used in power cable, and it's been used until now. A very good cable for underground cable that up 11 to 66 kV power cable. So we have self-contained field cable, SCFF. So inside this is the conductor, three-phase conductor. Then we have the fluid conduct. Then we have the paper insulated. Paper implement also in the was implement using oil as well. So we have the coverage. So this is all development of cable of been used since 1920s, used for underwater cable. So then use the electric fluid under certain pressure to maintain insulation integrity. Then the pressure need to be maintained by the reservoir installed in the main hole or in the substation. So cable shield at a pressure vessel. So we have the cable shield act as a pressure vessel and hermetical seal for the oil and also the cable. So then there are a few configuration of SCFF cable. So this one is the three-phase. This one is also three-phase. We have one single core at the where the oil is or gas is here. So they have paper impregnated. So it depends on the requirement, power requirement. So and relies heavily on no air or moisture entertained. So moisture and air, if in here, will degrade the system, the cable. So there are two categories: low pressure fuel and medium pressure fuel. So we have the third category, which is mesh implement non-drain or mine or solid insulate cable. So this cable, this is the conductor, and then this is the semiconductor. This is the paper permeated in oil. Then we have the shield, and we have the other layer of the insulator. So used for long distance HVDC transmission line, subsea cable, because there are a few connections under the sea. So for subsea cable, the insulator is important because it's operate under the water. So there are environmental effects need to be considered in order to have a very good efficient transmission line. So at extreme depth condition, the insulation system consists of lack of craft paper implement with the high viscosity compound and the cable rated normally at very high voltage, which is 500. And this paper now can be up to 300 layers. It depends on the size of the cable. So this is another type. So normally the cable is very high weight. So it can go up to 30 to 60 kg per meter. So it's a submarine. So we want it to be stay under the water at the surface at any condition of the water flow. So then the outer must be flexible. The cable can easily bend without affecting the insulating structure. So then the last type of the of the cable is the high pressure field cable, which is the pipe type. So inside the pipe, we have 3-phase cable. So most common type of transmission cable after World War II. So there are 3 cable installed and coated in the steel pipe. So there are pressurized line. So at when you use this one at the incoming end, there are plans to maintain the pressure of the inside the pipe. So require active cathode to protection to prevent, because they inside the pipe. So the pipe is tend to have a corrosion. So need to prevent it, because to maintain the pressure inside the cable. So the next application is the power capacitor. So power capacitor is known as power capacitor bank. So the capacitor bank used in the power transmission is to control the power factor. So we will have a good P and Q. So then provide leading current in the AC circuit. So the rate is between 55 to 1100 kilowatt for single phase, and it came up to 300 to 400 kilowatt for 3-phase unit. So all the design must meet the requirement of IEC 60871 or 18 or CSA C22.2 standard. So this is the indoor, this is outdoor capacitor bank. This is the indoor or in cabinet capacitor bank. So the capacitor is almost same as a power electronic capacitor. The difference is only it's a bigger. They have a lot of more winding. So we have a terminal, negative and positive terminal. We have a dielectric between the 2 metal plate. Then we have the insulation material, which is between the plate, and we have the casing. So plastic insulating and aluminum. So it's made by several layers of paper or insulator. So and aluminum foil up to 9 micro thickness of the electrode. So hermetical seal, it must be hermetical seal to prevent any oxygen come, because our atmosphere have water content, so we don't want it to be entered inside, then will degrade the insulation as well as the conductor. So the power capacitor should have high dielectric strength, high dielectric constant, good chemical, and also thermal stability and adequate viscosity for efficient conduction of heat. Okay, there are some power capacitor that the paper and the aluminum are immersed in the oil-based capacitor, power capacitor. So this is the category or properties of the insulation material of the power capacitor. We have tissue paper that separate the thin layer aluminum. So it can be a fiber composition. So and also this tissue paper must have unbalanced sulfide, and according to ASTM must have 100%. So ash less than 0.2%, moisture content must be between 4 to 8% only. So then the water extract from the value, then if the impregnating paper, so if you use mineral oil, if you use the IPN oil, this is another type of mineral oil insulation oil. So the next is the bushing. Bushing is the connector between the transmission line and the equipment. So for bushing, so we have capacitive and condenser bushing. So the operation is above than 50 kV. So the insulation material are treated paper. There are three types of treated paper. Paper which is resin bond paper, oil impregnated paper, and resin impregnated paper. So where is the paper here? So this is the conductor from the incoming to the outgoing, or from the line to the equipment. So inside here there are paper, insulated paper, and some we have oil inside here. So oil, we have a glass, the fill plug, then oil impregnate core, we have porcelain. Then the outer is can be made by using porcelain, by rubber as well. Then there are also non-polymer material as for the outer, this one for the outer insulator. So for resin bond paper, the maximum radius for the bushing is up to 20 kilovolt per centimeter. Paper is first coated with the epoxy or polyenoline. So then we have oil impregnated paper. The radius, typical radius stress is up to 40 kV per cm. So untreated craft paper and mineral oil. So then we have resin impregnated paper, can use for higher voltage, which is up to 50 kV or 30 kV or per cm. So there are crepe paper tape and epoxy resin being used inside the bushing. So now for the high voltage system reliability and economics is depend on the insulation condition and insulation selection. So insulation condition, that's why in high voltage monitoring, we are monitoring the insulation condition. So deterioration of the insulation can cause failure and casualty. So insulation material, we do testing to know the condition of the equipment and also to detect or to predict the fault inside the equipment. So insulation selection are very important. So the withstand property of the voltage stress, environmental condition, and dielectric strength, and also discharge activity are the factor that we must consider in order to use to select the insulation material. So for insulation material, the major important is the how the material the electric field intensity for the material. So we have E field. So E field, electric field where the particle is located. So it depends on the force of the test particle and also the charge of the test particle. So electrical field stress in the apparatus. So we can see that when we have the two conductor, this is the two electrode. So the positive and negative, this is conductor, being separated by the insulator. So here we will study the E field. So if the high E field means there are high potential of breakdown or in the insulator. So the insulator must can withstand the E field that being produced here by then, and also by studying the E field, we can select the best insulator and also to add more design to channel the E field so we can minimize the E field stress. So here is some software that we can use to study the E field. This is example of transformer. This is a cable. So when we see here we have the cable, three-phase cable. We study the E field distribution. Then when we add the shield, we can see that the E field distribution can be more uniform. Then the stress of the this area are more uniform compared to here. So now this improves the design of the cable. Same also here in the insulator, we can see the high E field here. So we can add or redesign in order to minimize the e-field. To e-field here to make the we can choose different material, can redesign the shape in order to minimize the e-field. E-field, what is the e-field? E-field between the two gaps where the average field same. If there are same plate or same conductor, the E-field here will be same, but the E-field here will be not same. So it's called uniform. When the E-field is same, it's called uniform. So the same force was applied to the material inside the region. So here example of E-field, uniform E-field. This one we do study. So using COMSOL. So here this is the insulating material. Here you can put it as a liquid or as air. Then we have the conductor, positive and negative. So we can study at what opening, what is the value of the E-field. Now is the homogeneous here, but here is not. Is a uniform E-field, here is non-uniform E-field, then we can find the highest stress here for the E-field. Then we can identify the best suitable insulated material to overcome. So, and also there is non-uniform E-field. So when you have the sharp point, so the surface area is changes. So definitely you will not get the uniform E-field. So this is non-uniform E-field. The E-field change according to the distance. The higher the distance, the lower the E-field. So here is some example to study the E-field. So here is some of the study. We study E-field for the SLPE cable. So here the study to see what if we have manufacturing defects where, because it involves the insulating material where it's a polymer. So polymer in the process to be hard, in process for the polymer to be shaped into the shape that we want. Sometimes there are air cavity or there are also water cavity trapped inside. And this water cavity and inside the cable will affect the E-field. So the example here we have the E-field with no cavity. So we will know that with this design, the maximum E-field is at certain watt value. Then when there are cavity inside with the void, so the E-field is changing. So then our material, insulation material, need to be designed so that it can at least withstand with the cavity size. This is the one of the steps to design the best insulating material. Selecting the insulating material, we will try different material and see how high the E-field with the cavity. So that's all from me for today. So I give back this the stage to the organizer.
Okay, thank you so much, Dr. Noor, for your presentation. I believe it's very insightful for everyone, for the participants, and including myself. I learned a lot today because my background is not engineering. So I learned so many new phrases today, so many words. Okay. We will continue to the next session, which is Q&A. I see a lot of the participants have sent a lot of questions here. Okay, so I think the first question will be from Faiza. She asked about, dear Dr. Nur Asia, what basic knowledge should students master first before studying high voltage engineering? Is there a specific
For
knowledge or? Mhm.
actually at the degree level, you have to take electrical or electronics engineering. It's okay for you to take electrical engineering, electronic engineering. But if you can take electrical engineering, then you will some of university will offer high voltage module or high voltage subject. So that will be the first channel to go for high voltage. Like me, I'm not in electrical degree, so I'm in the instrumentation degree, but I'm doing master in power. So then, when you do electrical power, so then you will already jump one step into the high voltage. Then I doing my PhD in high voltage. So actually, in high voltage, there are a lot of uh, a lot of uh, divert expert area. So in my area is insulating material, and I'm very special. My specialist in liquid insulation. So there are also in telecommunications where you do degree in telecommunication, then you major in high voltage. Where because in high voltage we also need a sensor in sensor to detect the fault. So the discharge, because the discharge is in terms of wave. So telecommunication also can go to the not only power, so but you also can measure in telecommunication and jump to the power system during master or PhD level. Then in high voltage, so there are one which is lightning, lightning expert. So for lightning expert, yes, you must start from the beginning as a power, but if not, you also can do during master. So in lightning, we also use a lot of telecommunications because lightning impact the telecommunication. You have to know the E-field, because E-field are being studied for many areas, not only high voltage. So that is how you can go. Actually, if you don't, but you have to in the engineering degree at least.
Oh, okay.
Not
Okay, so
uh, yeah.
because the term used in the high voltage industry is very technical or
Yeah.
very engineering, right? So you have to be at least have the engineering background.
Yeah.
Okay. So you
I have my PhD student. The undergraduate is mechanical, but
Mhm.
in master diploma, higher level diploma, he take electrical, then he jump to high voltage. So also can, but the basic at degree level must be engineering.
Oh, okay. So, for everyone who wanted to learn further about high voltage or want to take a degree about high voltage, you can take notes from what Dr. Noor said. Um, okay. So, the next question will be looking ahead, what trends or new technologies in high voltage insulation that the students and young engineers should pay attention to uh, and to what they want to prepare for the future industry needs.
Okay, for high voltage insulation, actually you will deal with the material. You have to know by who or by who you need to study even material, even though you don't have degree in material science, but because you are designing material that can withstand the current conductor, so you need to have knowledge on the material. So in material, there are a lot of new research, new technology. We have a lot of new material coming. Like I say, in insulation, liquid insulation. Last time we rely on mineral oil. Now we go to the because of the environmental friendly, because of the flash point, yeah, lower flash point. So there are new research on the not new, they're already 20 years old, which is vegetable based. Then now there are synthetic based. There are also nano liquid, because now there are a lot of compound can be designed. So based on the new material, new finding from other material science that you can adopt into the insulation material. So you have to aware also in the progression of the material technology. So, and also now we have a lot of sensors for detection. So there are a lot of IoT and AI because in high voltage condition monitoring, you also need AI because beside of the experience to do diagnosis, you also can develop AI that can recognize pattern, so can give you early prevention or early detection. Same as medical, where you have a certain signal, it will indicate what is the condition of your equipment. So same, medical, you have a symptom, then your doctor will do the diagnosis. Same as a high voltage equipment. We want to do condition monitoring, we need to do diagnosis. So there are also some area where you do the condition-based material monitoring. You need to know the AI, you need to know all the pattern recognition as well.
Okay, so that the students and young engineers should really pay attention to the research updates, right? So they be able
It's
to follow the trends.
It's a cross-disciplinary because high voltage itself is the traditional, but now there are a lot of technology and helping tools that we have to adopt into our system. So high voltage now we shift to smart transmission line. So we have a lot of data analytics. So we also need non-engineering background that need to have some fundamental training for certain module. So he can do the data analytics to do early prevention or prediction of faults.
Okay. So you mentioned before that right now in high voltage, there's a lot of technologies and equipments, right? Can you describe how the engineers evaluate electric field stress within using high voltage equipment, and how existing tools can help improve insulation design before the equipment is built?
So for insulation, high voltage, if it is stress, is the main major concern. So the insulation must able to withstand that refill. So how we can measure refill? So for the modern technology, we have before we design, before we fabricate, we can use a lot of software, which is finite element software to do the design. We have the proper design before we fabricate because most of the electrical equipment is a big equipment. It will be costly. So then the field design is not the option now. Even for manufacturer, they will do proper simulation first using finite element software to do design. So to select the best material, to know the thickness of the material, then they fabricate. Not at the last time, all these they are backward, which they do the study, then they do test. But now currently we have a lot of software, then we can do design first, we test under E-field condition, we know the E-field, maximum E-field, then we can modify our design, structure, construction, and also the material type, the material thickness. Then after that we fabricate. Then for E-field, there are certain sensor can measure E-field. So in practically lah.
Thank you so much for the
even the discharge, when we have a partial discharge, the equipment are in operation. There are conditions where there are partial discharge. So there are technology which is not interrupt the system. You have the partial discharge, UHF sensor, very high frequency partial discharge sensor. So there is on the telecommunication and sensor part.
So the technology updates really help with the equipments used in daily
Yeah, we
to
try
make it more convenient.
it is like human. We have now a lot of medical, a lot of exercise. We have then same as electrical equipment. Nowadays we have a lot of tools that help us to monitor and do preventive maintenance and know the condition of our equipment. in order
Okay.
to make our transmission line work at the best condition.
Okay. So the next question is from Faisal Hadi. He asked about, could you clarify the role of the cable sheath in acting as a pressure vessel and a hermetic seal?
So because in cable, so we have the conductor. When we have the conductor, we have the current flow. Then we have the current flow, uh, definitely we will have a voltage a potential. Then there will be electrical stress, which is electrical field. So like I say, the electrical field can be uniform electric field and non-uniform electric field. If you see my slide at the end, we do study. So when we don't put the shield, the E field become which is not symmetric, which is not homogeneous. So there are different level of E field. We try to minimize non-uniform E field. So because if there are one point that have high E field, so mean that point the insulation will be degrade first. So when it's degrade first, it will break up. It will break. So then it will short. It will be short circuit there. So if we can produce uniform E field, so all the insulating material experience the same force, the same E field. So there are no weak point lah, at least.
Okay, thank you so much, Dr. Noor. I think I have a last question for myself. You mentioned before that there are different types of oils, such as minerals, synthetic, and plant-based oils, right? And how do these oils compare in terms of performance, environmental impact, and long-term stability in real operating conditions?
The last past, I think past 15 years, mineral oil is the best, the most common use. But in late 20s, 20 year back, there are new coming, not new, actually vegetable base is been studied before mineral oil, but after mineral oil come, the vegetable base been forgotten because of the moisture content and everything. Then after mineral oil been established more than 100 years, there are an issue of the environmental issue, which is the mineral oil are very hard to absorb in the soil. There are easy fire. You can see when there are cases where the transformer or substation are on fire because the fire point of the mineral oil is lower. Then we are starting. There is where the time I'm start my PhD, where we are looking for replacement oil or alternative oil to replace or that can work best as mineral oil. Then we study ester-based oil. Ester-based can come from a lot of source. There are some commercial now, which is from the sunflower seed. There are from soy base. There are from Japan. There are from rapeseed. Even Malaysia now they are do from the palm oil. This oil are being categorized as a ester oil, natural ester, because it's from natural product. Then these all have their own advantage, which is they can tolerate more on moisture compared to mineral oil. So if they are inside the transformer, there are a lot of moisture, they can withstand, they cannot break down compared to mineral oil, because mineral oil is mineral based. At some point, the moisture inside the oil become the water bubble. And then the water bubble, water, the properties is semiconductor. At one point, it can become the conductor. At one point, it can become the insulator. So if there are too much, it's become the conductor inside when it's work in the mineral oil. But in vegetable oil, even though the moisture content is high, it still act as an insulator. So then there are, but vegetable oil, there are problem of oxidation because it's a fatty acid base. Then there are problem with the viscosity. Then that is my research to improve the viscosity, to improve the oxidation. We try a lot of material thing, add antioxidant, add nanofiller. There is a progression of the research.
Oh, okay. Thank you so much, Dr. Noor, for your answers. That concludes our Q&A session because we're running out of time, but I believe the participants still want to know more from you. But so we don't have much time left. So we have to continue for the next session, which is group photo. So I would like to call all participants to open your camera and use the virtual background that provided so that we can have a group photo together. And then after the group photo finish, my college will send the attendance link that fill with the certificates. Okay.
Okay.
Wait. Okay. Please open your camera. Okay, I think everyone. Okay, we will start from the first slide. 1, 2, 3. Next slide. 1, 2, 3. And then last slide. 1, 2, 3. Okay. Once more. Okay, thank you so much. Once again, thank you so much, Dr. Noor, for joining us today and share your knowledge with us, especially in the high voltage and installation materials. It really means a lot for us. It's very insightful. Thank you so much. Do you want to say something for the participants, Dr. Noor?
So thank you for listening. And if you have any question on the career or in the journey for high voltage, you can email me. So because in high voltage, you are not only as a researcher or the engineer, in technical level, also there are different category, which is like a judgment, competent person. So you can email me if you want to know more about the high voltage area.
Maybe could you please share your email in the chat box, so if there's someone who want to email you, they could.
In my first slide, I already put it, which is at asiah.muhammad at utb, asiah.muhammad, ASIAH dot MUHAMAD at utb.edu.bn.
Thank you so much, Dr. Noor, for your for your presentation today once again. And I will help you to send the email to the participants. And for all participants, the attendance link have been shared by my college. You can fill it now. Okay. Once again, thank you so much for coming, and see you on our next webinar.
Okay, thank you so much.
Thank you so much.
Assalamualaikum.
Waalaikumsalam.